Okay, so for learning target 5, it brings us back to rate of change. And by starting, before we start this, I want to kind of just remind you what rate of change is. It's nothing new to you. You've seen it. You saw it a lot last year, actually. So do you remember when Mr. Meeks talked to you about unit rate? And you did all those worksheets that if you buy a box of pencils and there are 12 pencils in there and you pay $2.11 for the whole box, how much is it for just one pencil, right? So unit rate was how much for one, right? Okay, yep, how much for one. And then we turned unit rate into something called constant of proportionality. Do you remember that? Okay, I see those looks on your faces. Constant of proportionality. And that was when you had a table that looked like this, right? It had 0, 0, and then it went up at a constant rate, right? That was constant of proportionality. So it went straight line through the origin. But it was still how much for one, right? And do you remember what letter of the alphabet we used for that? It was weird. You would think it would be C, but it wasn't. It was K. Did he tell you K? So for this here, K equaled 10, right? Do you remember that? So K is another, what they use for constant of proportionality, okay? 5, learning target 5. Okay, so unit rate means how much for one. Constant of proportionality means how much for one. Last year you learned about a word called slope, right? That also means how much for one. But another way to say that, so let's just, I guess, go do another arrow. Slope also means how much for one. And another name for slope, which we're going to talk about today, is rate of change. And the slope was the rise over the run, remember? So basically what I just showed you is there are 4 different ways to say the exact same concept. All of these things mean how much for one. How much for one. What is it changing by? So this is the first way, second, slope, and then rate of change. So we're going to revisit slope again this year a lot, but we're going to start with rate of change. So all these things just mean unit rate. So as I'm looking at this table right here, if it contained the point 0, 0, it was like a bonus, right? Because if it contains the point 0, 0, and it's going up by 1, so let's just make this workable. Let's just say X is the number of hours that I babysit for, and Y is the amount of money that I make. So if you don't babysit for any hours, you don't make any money. That's usually how it works, right? Okay, 0, 0. So if you work for 1 hour, you earn $10. 2 is 20, 3 is 30. That was pretty easy for you to do last year. And you remembered, because the numbers weren't always this easy, right? Mr. Meeks was good at giving you like fractions and decimals and all those other kinds of numbers. But you knew that if you divided all of these numbers, all of the Y values, by all of the corresponding X values, that you got the same number every time on your calculator, right? That's the definition of a proportional relationship. It means all of these numbers are exactly 10 times so actually, look at it this way. Do you know why the equation was Y equals 10x? Because every one of these Y values equaled whatever the X value was times 10, right? So if I plug this in for X, 10 times 1 was 10, which is Y. So that was the equation Y equals 10x, right? Okay, so that was the first part about it. Then let's take a look at some of our other tables, because you're going to see them sideways as well. So let's say, so everybody was okay with finding the rate of change here. So the rate of change for this table was 10. Piece of cake, right? How much for 1 hour, how much for 1 mile, how much for 1 minute, whatever that is. Now, sometimes they could get a little tricky and say 2, 4, 6, 8, and then 40, 80, 120, 160. And this one wasn't as easy because they changed up two things on you. First of all, you don't see the .00 anywhere, which doesn't mean that it's not in that table. It just means you don't see it. And they're not going by ones. So they hit you with the double whammy. This is the easiest kind of table right here, when you can see 00 when it goes by ones. Okay? Yes. Oh, no. Oh, okay. So the first thing I want to look at it is, okay, for every 2 that this goes up, so meaning for every 2 hours that I work, I earn another what? I earn another, for every 2 hours right now, I earn another $40, right? Does this mean I make $40 an hour? No. It means I make $40 for 2 hours. So when this doesn't go by ones, it's kind of like, oh man, but you just take the change in your Y values and divide it by the change in your X, right? So for every, so really how much do I make an hour? 20. So 20 is my rate of change, right? Okay? So, and here's what you're going to have to do. Because if I go and look up here, see how this was going by tens? Somebody who maybe doesn't think a lot and just kind of writes down part of what they remember me saying might look at this and say, the rate of change is 40. It's 40 for every 2 hours that you work, which means it's 20 for every one. So, and here's the deal with this. What does 00, is 00 contained in this graph? For every 2 I go up, let's go back 2. For every 40 I go up, let's go back 40. So is this proportional? Do you want to see why? Because 40, I know you could do this in your head, but I want you to see it. 40 divided by 2, 80 divided by 4, 120 divided by 6, right? So that number's all the same. So, but that's too easy for advanced algebra, right? Because we're going to give you next a table that looks like this. So is everybody okay with how we got 20? Okay. So the next table you're going to see is going to look like that. Meaning, that's a game changer. Right off the bat, you know it's not through the origin anymore, and that screws everything up. Let me just kind of show you what I mean by that. So if I have 0, 5, 1, 15, 2, 25, and let's put one more in there. Okay? Now, if you were in 7th grade right now, in my 7th grade class, they've never seen anything other than 00. So you know what they would probably do first? They would probably grab their calculator, and you can't divide 5 by 0 because look what happens. It's division by 0 is not possible, so your calculator is going to give you an error message. So 15 divided by 1, yes, they would do that in their calculator. 25 divided by 2, and then they'd go, oh, it's supposed to all be the same. And then they would do 35 divided by 3, and then they're not really understanding why this is not the same. Why isn't that all the same?
Because $5 is like the down thing.
Yes, okay, because that 0, 5 throws a wrench in everything. It means, what does it mean if this was your babysitting? This is the number of hours that you work, and this is the money that you make.
So you get $5 just for showing
Yes,
up.
yes, that's exactly what it means. They pay you $5 just for showing up. So when they're walking out and going to dinner and the movies, and you're walking in, they hand you $5. You didn't even work, but they still gave you $5, which is great. That would be awesome. But how much do you earn per hour? 10, right? So for every 1 that this is going up, and as soon as you see that that's going up by 1, you're like, woohoo, because it's a bonus. You don't have any extra thinking to do, because whatever number this is going up by, that's your rate of change. As long as that's going up by 1s. So for every 1 that goes up 10. So my rate of change is 10. Okay? I just need you to know that if it doesn't contain 00, it's not proportional. And all of those numbers don't divide and equal each other. Or equal, you can't write an equation like y equals 10x. No, it doesn't. Y equals 10x plus 5 or whatever. Okay? All right. So that's the rate of change for that one. Now, they're going to try to trick you even more. So let's say 2, 4, 6, 8. So as soon as you see that, you're on high alert because you're like, okay, this is for every 2, not every 1. So find the rate of change for that. And if you want to look at it as, babysitting, if you want to look at this as the number of items and this is the cost that you pay or get or whatever. So right away I noticed that this is not going up by 1, so I got a little extra work to do, right? So for every 2 that goes up, this goes up what? 6. If it's proportional and it has 0, 0, listen guys, here's the main difference. I can divide the y by the x, right? Just like I did here. 10 divided by 1 is 10. 20 divided by 2 is 10. 30 divided by 3 is 10. Those are the actual y's divided by the actual x's, right? When it's proportional. When it's not, you can't divide the y by the x. You divide the change in the y values by the change in the x values. Do you remember that from last year? Should be a review. So for every 6 that it goes up, that's for every 2. So I'm making $6 more for every 2 hours I work. I must be babysitting for my mom or something because she's only paying me how much an hour? $3 an hour, right? So my rate of change is 3. Understand that? So for every 2, it goes up 6, which means for every 3, for every 1, it goes up 3. Okay, so then we got to start making them a little trickier. So if I have 1, 2, 3, 4, -4, -8, -12. Okay, just think about your number lines. So the good news is it's going up by 1s, so I don't have a lot of work to do here. All I have to do now is find out what these are going by. And sometimes your rate of change doesn't always go up, right? Could this be, well, you tell me, what's happening here? JC. Yes, it's going down 4, because if you think about a number line, if you're at -4, you take 4 hops to the left, you're getting further from 0. You're going down 4. So as long as this is 1, is this my rate of change? Can you think of a real-world example to match this table? What would that mean if for every 1 something, the other something goes down?
Like every hour the temperature.
Yes, that would be great. For every hour past midnight, the temperature decreases 4 degrees. Good. Okay? It could mean for every, you have some money in your bank account, and for every app you purchase, or you have money on your iTunes card, and for every app you purchase, they're fancy ones, your balance goes down 4. Okay? Very good. All right. So now let's take a look at another one. 1, 10, 3, 40, 7, 100. Oh, I know you're like, what? Because this is ugly. So I really want you to think about this. Because first of all, it's not going by 1s. Second of all, that went up by 2, but that went up by 4. So the x's aren't even going up. So how do you think you could do this? Go ahead and take a minute and try to see. Maybe treat it as 2 separate problems. Maybe do these 2 first, then do these 2. So see if you can come up with a rate of change for that. I think you can do it. For every 2, it's going up 30. And for every 4, it's going up 60. So how much is it going up for 1? Try to get that answer. Divide the change. So like first, pair these 2 points together and see what you get. With those change in y and those change in x's. And then pair these 2 together and see what that gets. Does anybody think they have it?
Yeah.
What do you think? 15? Awesome. Because for every 30 you earn for every 2 hours, that's 15. And here you're earning 60 for every 4 hours. So, you got this. Yes, it just skipped a couple. So it kind of would have been nice if they put a 5 in there, right? And you can look at it like that too. If it would have made you more comfortable to put a 5 there, and what's halfway here between that and that is what? It has to go up by 30, so this would be what? 70. Yep. Okay. All right, so try this last one then. And if you can get this, then you should be good. Oh, sorry. Thank you. So it's going up, how much for every 3? Yep. For every 3 that this goes up 6, right? So you earn $6 for 3 hours, which means 2. Now, I should do the other one just to check, but technically, I mean, that should be, if it's linear and they're not tricking you. When I earn 12 for every 6 hours. So did you get 2? Okay, awesome. All right, that is learning target 5.